No, ma'am, you're not audible.
Now also not audible.
Now you're audible.
So in the yesterday's session, we were discussing the elimination reaction. Okay. So in elimination reactions, what happens from your alpha carbon, halogen is removed, and from the beta carbon atom, your hydrogen is removed. Okay, and we put a double bond between them. So it is your elimination reaction. Okay, which is also known as your dehydrohalogenation reaction. Okay. So let us see this important point here that if we use NaOH, which is in ethanol, then an elimination reaction occurs and alkene is the product. But if we use NaOH in aqueous solution, not phenolic, okay, we use the aqueous solution of NaOH, then your substitution reaction will happen. Or which will happen, nucleophilic substitution reaction will happen. And then alcohol is one of the product in that case. Okay, so alcohol is one of the product in that case. That means if you do it like this, if you use NaOH in ethanolic form, then only you get alkene. But if you do this with NaOH in aqueous form, then the substitution reaction will happen. The OH come and bromine will leave. Then this is your product. Okay, so see how much difference is there in the reagent. Okay, ethanolic NaOH and aqueous NaOH. So write this down.
And I'm also done.
This is your homework question for today. That write a balanced equation for the reaction of 2-bromopropane with ethanolic sodium hydroxide. Ethanolic, okay. Name the organic product. Discuss with a partner another elimination reaction with a different bromoalkane that would give the same products as in part A. So remove another alpha hydrogen, okay, because there are in 2-bromopropane you have 1, 2, 3 at 2-bromopropane. Okay, CH3 and this is CH3, this is CH. So you have to write down a balanced chemical equation for this with ethanolic sodium hydroxide. Whatever would be the product of this reaction, so you have to tell a different bromoalkane which would give the same product. Done?
Yes. Yes.
So what we have studied, actually the chapter is completed in this in your course, only this part is there. So we have seen that if one or more of the hydrogen atoms in an alkane molecule, they are replaced by halogen atom, then it is called your halogenoalkane. Okay. Then iodoalkanes, as we studied, they are most reactive halogenoalkanes, whereas fluoroalkanes, they are the least reactive. Okay, reactivity increases down the group if we see the halogens, and iodoalkanes are most reactive and fluoroalkanes are the least reactive. How can we explain this? By the trend in the bond strength of the carbon halogen bonds. CF is the strongest bond and the Ci bond is the weakest bond. So it is easier to break the Ci bond during the reactions. Next, we have studied that halogenoalkanes, they are attacked by nucleophiles. Why? Because the carbon bonded to the halogen, it carries a partial positive charge due to the higher electronegativity of the halogen. So halogenoalkanes, they can undergo nucleophilic substitution reactions easily. So suitable nucleophiles include your aqueous alkali, cyanide ions, ammonia, in which your nitrogen will have lone pair of electrons to attack that carbocation. The reaction with OH minus ions or with water, it is known as hydrolysis reaction, and an alcohol is formed as the organic product. Next, the elimination reactions, halogenoalkanes, they will undergo elimination also when it is heated with, heating is necessary in elimination reaction. When it is heated with ethanolic sodium hydroxide, forming alkenes as the organic product. Okay, so if you are taking NaOH alcoholic, then you are having alkene as a product. But if you are having aqueous NaOH, then you are having alcohol as the product. Okay. So if this chapter is clear, then please answer some questions. Please answer this question. What type of reaction best describes the heating of chloroethane with ethanolic sodium hydroxide solution? Which option should be correct? This is the 1 mark MCQ. What should be the correct answer?
Is it elimination?
Yes, it is elimination reaction. So the reaction of heating your chloroethane with ethanolic sodium hydroxide solution, it is your elimination reaction. So I hope it's clear. If anyone asks you to define the elimination reaction, so in elimination reaction, it involves the removal of atoms or groups from a molecule and it results in the formation of a double bond. So in this elimination reaction, your ethanolic sodium hydroxide, it acts as a strong base and it promotes the elimination of a hydrogen atom and chlorine atom from the chloroethane. So it leads to the formation of ethene as a product. And it eliminates a small molecule of water also. So next question is, which one of the following is a tertiary halogen of alkane?
D.
D. Let us check. It is C, CH3, CH3, Br, CH2, CH3. Yes, D is the correct one because this carbon is attached to three other alkyl groups, so it is a tertiary halogen group. To solve this question, which one of the following will form a carbocation in the mechanism of nucleophilic substitution?
B.
B or D?
B.
B, right?
Yeah.
Yes, very good. Because we have to check carbocation formation and we know that 3-degree carbocation is more stable than 2-degree, than 1-degree carbocation. Okay, so if we talk about this, then it is your 1-degree, which is very less stable. If we talk about second one, then it is same CCH3, CH3, and then we have Br, CH3. So it is a 3-degree carbocation. Okay, it will form a carbocation. Bromine will leave from here, and positive charge will develop from here. Okay, so this is your tertiary alkyl halide. It will form a tertiary carbocation, which is most stable type of carbocation. This compound is highly likely to undergo your SN1 reaction. If we talk about this C part, it is also 1-degree, and D part, if we talk about it, is also it is a methyl halide. Okay, so it would form a methyl carbocation when bromine will leave, and it is the least stable type of carbocation. Okay. Solve this question. When a solution of potassium cyanide in ethanol is heated under reflux with 1-chloropropane, what is the organic product of the reaction called?
Hey students! Interested in boosting your studies? Enroll now at Keddy Edtech. We offer online tuition for the Cambridge curriculum, grades 6 to IGCSE, AS, and A-level. Start learning with us today.
What should be the answer? Elimination reaction is this, I think.
D.
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 You are saying B or D, Alicia?
D.
So when a solution of potassium cyanide in ethanol is heated under reflux with 1-chloropropane, this is my 1-chloropropane. you have potassium cyanide in ethanol. Ethanolic solution of potassium cyanide, and you are heating it. What happens? Chlorine will remove. Just a minute. When a solution of potassium cyanide in ethanol is heated under reflux with 1 chloropropane, what is the organic product of the reaction called? So here what happens? Nucleophilic substitution reaction will happen, which will replace your chlorine, atom with your cyanide group, CN group. Okay, so it is your CH3, CH2, CH2, CN. Is this the product? Are you getting the same product? Am I audible?
Yes.
So are you getting the same product like this?
Yes.
Okay.
Yes.
Yeah, so is it propane nitrile or butane nitrile?
Ma'am?
Like it is because there are 4 carbon atoms in this, so it should be butane nitrile or propane nitrile. There are 4 carbon atoms now, and the root word for 4 carbon atom is butane. Okay, so it is butane nitrile, not propane nitrile. Propane nitrile is CH3, CH2, CN. It is your propane nitrile. So the answer should be A1. Got it? This is the UPSC. You have to remember in cyanide, you include this carbon of cyanide also. So in butane nitrile, you will have to include this nitrile carbon also. So there are 4 carbon atoms. So it is option number A, not option number D. To solve this question, 1-bromobutane will undergo reactions when heated as shown by reactions A and B. So for reactions A and B, give the reagents used in each case first. In the first part, for reactions A and B, give the reagents used in each case. So in reaction A, what should be the reagent used? It is the conversion of 1-bromobutane to 1-butanol. So this is your nucleophilic substitution reaction. So what should be the reagent you are using here? Aqueous NaOH, right? And in B part, an alkene is forming. So it is an elimination reaction. This is your substitution reaction. And this is your elimination reaction. So which reagent you are using in B part? So you would use a strong base in alcoholic solution. So I can write alcoholic, NaOH or KOH, anything. Okay. Next question, solve it. Reaction A was repeated using 1-iodobutane instead of 1-bromobutane. So what should be the difference in the rate of reaction? Is it fast or slow with 1-iodobutane?
First.
I said it would be
Pardon?
faster.
Yes. Rate of reaction would be faster with one iodobutane. Why? Because iodine is a larger atom as compared to bromine. So if it is a larger atom, so the Ci bond, it is long and weak. The Ci bond length is long and weak. Long bonds are always weak. So it is easier to break this bond. So this is, as it is weaker bond, so it is easier to break it. So rate of reaction will increase. Name the type of organic reaction shown in A part. Tell me the name the type of organic reaction which is shown in A part, A reaction. Is it substitution or elimination?
Nucleophilic substitution.
In substitution, it is SN1 or SN2?
SN2.
Yes. So the reaction is SN2. Why it is SN2? Because it is a primary alkyl halide, and we know the rate of reaction for SN2 is 1 degree, then 2 degree, and then 3 degree. So it is a primary alkyl halide. This carbon atom is connected to only one carbon atom, so it is a SN2 reaction. Because we will see the reactant first, it is 1 degree. Then we will see the reagent also. So it should be a strong nucleophile, which is here we have OH minus. Okay, so it is a SN2 reaction. Next question is draw the mechanism for reaction A. You have to draw the mechanism. So how many steps are there in this reaction in SN2? 1 or 2? Only one step is there in SN2 mechanism. There is no formation of carbocation. Okay, so you can call it a single concerted reaction, single concerted step, where you can easily draw your OH minus ion will act as a nucleophile and it attacks the electrophile and leaving group will leave in the first step only. Okay, so it is a one step reaction. You can write it in one line. And this is again your homework question. Write it down. 2-mark question. The question, you can see that this is a lengthy question, but marks are only 2. So you have to just draw the displayed formula and then you have to just reduce the name of the compound.